Our final introductory slice of why we're learning C++ is a summary. It'll be short and hopefully reasonably sweet. So why bother learning C++? Why are we going to go out of our way to look at the language, how it's structured, how code gets to be compiled, gets to be executed? There's a couple of reasons. So it says here, C++ has considerably evolved and developed over its 30 years of existence. That's true. Used to write low-level code or to develop large enterprise solutions. Well done. This means the language is large and complex, and with 30, 40 years of evolution, it's also slightly messy. There is actually, believe it or not, some merit in having a look at this, because it does help highlight, and hopefully it helps build a better appreciation that if we're thinking about programming languages, they're not static entities. They do evolve and change over time. And the best way to think of it is that there's a large family of different programming languages that are available to offer different types of feature. And we as programmers, given a problem, should be sitting thinking about, well, what is the right or the best language to enable us to most easily, most capably, most safely to develop a solution for that particular problem. And again, when we see this, we can better understand and have a look at how languages are going to change in the future, the types of language features that are going to emerge. So it's not unreasonable. I mean, as you expect, the computing capabilities have changed quite massively. Equally, the languages that we use then to make use of those capabilities, they too also need to change. And looking at C++ will give us a bit of an historical perspective on many of those aspects, but that will be of help. Beyond that, it says relative to Java, C#, or C#, C++ is often viewed as a somewhat less friendly and more dangerous language that will bite if you do something wrong. And that's actually largely true. It will not, or is likely not to be a pain-free process learning C++. There's likely to be a lot of frustrating debugging and fixing within it. And for us to write good C++ code, we're going to have to be careful about what we write, and we're going to have to understand at a deeper level than maybe we might do within Java or C#, how the stuff that we write, what it actually will do, what it actually means, how it will get to be executed through the process of compilation and turned into something. And it's useful, very, very useful to understand that, to look at that slightly lower level down. Because C++ is a reasonably low level language, it exposes a lot of these aspects. It gives us as programmers the ability to get in there, to write code that does this, to manipulate things at a lower level than otherwise we could within, say, Java or C#. So in doing that, in delving down to that slightly lower level, even though it may be slightly painful, it's going to give us a much better appreciation or understanding of how the programs that we write in any language get to be turned into code that can be executed on current processors. And that's the type of understanding that we want. As mentioned in the previous lecture, the introductory slice, if we have a goodish understanding of how the stuff that we write gets to be executed, it means that we are much more likely to avoid doing silly things that could introduce very high performance penalties or might just be fundamentally not good practice overall. So there's a couple of reasons as to why it is actually worth our time to go through a little bit of pain to get an appreciation of C++ by way of making us better programmers overall.